So we're just in our 3-3, and we're just going to do kind of as many problems as we can for the next little bit. Again, we've done logs before. Oh, Grace just jumped in. Let's see if Grace has a pet check. Hi, Grace.
Hi.
I hope your oral exam went well. We just spent the whole first part of class doing pet checks. So do you have a pet for us to share?
I wish, but
Oh,
I do not. And I'm sad I missed that. Dang it.
Oh, I'm so sorry, Grace. Anybody close enough to their pet to show us now? Give Grace like a quick little pet check. Oh, there's a dog. Ava has Barkley.
Barkley, my favorite.
And that is all I see. So awesome. Okay, cool. I'm glad that was all recorded. So whoever goes back and watches this gets a snippet of our pet check. So we've done logs before, and all we're doing is evaluating. So when they're written in this form, let's break it down first. I have a log, and then I'm going to write it like this. Log base b of y equals x. I just wrote this off to the side. This is just the basic form of logs. And so we say it as log base b of y equals x. So that's how I physically say that. B is the base, x is like the answer, or is the exponent, and then like y is the answer. So the way I was taught about logs is something called a log roll, which means that I'm going to kind of roll around this shape in order to find it in exponential form. So I always start with the first number I see. So in this case, it's the base. Log is not a number, it's a function. And I go from b all the way across the equal sign to x, and then I roll through to y. So that's going from log form to exponential. See how I did a big cursive E there? I rewrite this as b raised to the x equals y. So if I want to switch between log to exponential form, I do what I call a log roll, and I go from base across the equal sign through the y. If you want to go backwards, I just also call this a log roll. I don't think it's got a special name. But again, you start with the first number you see, you go across the equal sign, and then you come back. And that kind of looks like an L to go into log form. So you make an E to go to exponential form, and then you make what's kind of like an L to go to log form. We're going to do the exponential first. So we're going to do all of the ones that look like this, going from log to exponential in order to help us solve it by hand. So I'm going to come over here. You can write a little X over the other side so you have an equal sign somewhere to roll to. It doesn't say without a calculator, but we're going to do these without calculators. So I'm going to go from the first number I see, which is 5, across the equal sign through the other 5. So I go 5 raised to the x equals 5. Anyone have questions on just like my mechanics of the log roll? Do you call it something else with another teacher maybe? Okay. Now I have 5 raised to the x equals 5. Well, 5 to what power would be 5? 1. And so I'm just writing what the exponent will be. 5 raised to the first will be 5. All right, I'm going to just keep going down the list. Same thing. I'm going to do now 4 raised to the x equals 16. 4 raised to the x equals 16. Well, 4 to what power would be 16? 2. Any questions so far? Okay. The next one says ln. Remember that ln is the same thing as log base e. So instead of writing ln, I could have written this as log base e of e raised to the 10th. If I set that equal to x in order to log roll, I'd start with e, I'd say raised to the x equals e to the 10th. E raised to the x equals e to the 10th. Oh, well, e to the x is equal to e to the 10th. They both have an exponent, and so x equals 10. On D, I've got this cubic root, which is the same thing as writing ln of e. Cube root is 1/3 as an exponent. Again, you can think of it as base e and equals x. So I'm going to do e raised to the x equals e to the 1/3. E raised to the x equals e to the 1/3. So again, x equals 1/3, just equals the exponent. Am I moving too fast or are we doing okay?
On the ln, is that the opposite of the log?
ln means log base e, so ln means natural log. And so it just means instead of having like log base 4 like that one is, it's just the same thing as with the base of an e.
Oh, okay. And then, but then it has the exponent, so you know which number to do? Like with the 10 next to the e?
Well, it just means that my problem is set up, so I'm doing e raised to the 10th power. So that's what I'm doing my ln of.
Okay, I think I kind of get that. So you're not solving for it to figure out the variable this time, or the exponent this time. You're solving.
So my exponent doesn't necessarily matter. My exponent is always what's on the other side of the equal sign. And so what's on the other side of the equal sign was x. I just also happen to have an exponent in like what you're doing of the log of.
Got it. Okay, I think that makes more sense. Thank you.
We'll do a few more and hopefully it'll start picking up. Okay, if you have a number raised to the power of log to that same number, that just crosses out. And so my answer is 10. So when you have a number raised to a log of another number, these are all properties of logs. So we're just kind of doing a big group run of all of these properties of logs. I don't have a better explanation for that. It's just the base of my exponent has the base of the same log, so those cross each other out. They're inverse operations. Same thing for the next one. It's 8 raised to the log base 8 of 2. My answer is just 2. Got a few more in this column. Ooh, now I have a number out front. Remember that a number out front of your log is the same thing as an exponent. So that's the same thing as being an exponent for that 2. So instead of this, I could have had it written as log base 2 of 2 to the 4th. Still, we'll set that equal to x and we'll log roll to solve. 2 raised to the x equals 2 raised to the x equals 2 to the 4th. So again, x equals 4. H is a lot like letter F. E raised to the ln of 6. Well, e and ln cross each other out, and so my answer is just 6. Log base 8 of 1 equals x. Log roll. 8 raised to the x equals 1. What number raised, 8 raised
0.
to what number? Very good, thank you.
I knew what you were trying to say, so I was like, I'm just going to say the answer.
Laura's like, I'm going to help her out because that was a mess. Yes, I couldn't even word my question. The answer is 0. Anything to the 0 is 1. And then the last one in this column, I've got a square root. And so that's the same thing as doing log base 7 of 7 to the 1/2. And so that 1/2 is my exponent. Log roll it. And I get 7 to the x equals 7 raised to the 1/2. X equals 1/2. Exponents equal each other. All right, what questions do we have so far? All right, let's keep rolling on that. Do you want a second to try the other side and then we'll come back and talk about it together?
On
on H. Can you go back one?
Talk about number H again. So letter H is one of those where I'm raising a number to a power, and in that power, I've got an exponent. So since it says e raised to the ln of 6, that's the same thing as e raised to the log base e of 6. And when these numbers match, then they cancel each other out because they're inverse operations, and we're left with just 6. Does that help?
Yeah, thank you.
You're welcome. I wish I had a better explanation on that. I just know that if the base of the number and the base of the log are the same, they cross out. All right, take a minute, try some of K through T, and we'll go over those all together in a second. All right, I'm gonna jump in with you guys. Number K already poses something that looks a little different. I've got log of 100. If there's no base there, remember the base is 10. So that's the same thing as doing log base 10 of 100 equals x. So I can say 10 to the x equals 100. So 10 to the second, 10 squared would be 100. Similarly for the next one, I hadn't looked at this yet, but now I'm going to look at some negative exponents because I'm about to do 3 raised to the x equals 1 over 9. Well, remember, if it's in a fraction, it's like if we had that negative exponent that flipped it. So that's the same thing as 3 to a negative exponent. And if it was 9, then 3 would have had to be squared. So 3 to the negative second is the same thing as 1 over 9. I have to write it in terms of 3 because only if 3 is raised to an exponent do I get to set them equal to each other. And so x is equal to negative 2. All right, let's keep going for the next one. I've got log base 6 of cubic root of 6. So I'm going to do 6 to the x equals cubic root of 6. Well, we can rewrite that cubic root as being raised to the 1/3. So I've got 6 to the x equals 6 to the 1/3. So that means x equals 1/3. Again, each of these I'm working to get the base to be the same so their exponents can be equal, or I can just know what it is. So like I didn't have to make 100 be 10 to the what power. We know 10 squared is 100, so that was easy for us. All right, of the last ones, N through T, are there any ones that we should do? NOP, QRS, or T?
Can we do
We
it
did
all?
Can we do which ones?
all.
Oh, all of, okay, yeah, just keep rolling, says Laura. Sure. ln 1 over e to the third. Remember, ln is the same as having a base e. So I'm going to roll this guy again. E to the x equals 1 over e to the third. Like we just talked about a second ago, if it's in a fraction, make it negative exponent to flip it. So I can make that e to the x equals e to the negative third. And now I get to just set my exponents equal to each other. We're going to do the same thing on the next one. This one's just 4, which is a little bit more familiar to us, but that's okay. 4 to the e equals 1 over 16. Or sorry, 4 to the x. That was my bad. 1 over 16 is the same thing as 4 to the negative second. Are we all okay with that, or am I speeding too fast through that? Just let me know, okay. That means x is negative 2 because 4 to the x is the same thing as 4 to the negative 2. Letter P, 10 raised to the log of 7. If there's no base for my log, we assume that it's 10. So I can just cross those off and I'm just left with 7. Again, not a lot of work for those. Next up is Q, log of 1,000. Again, no base there, so I've got base 10, and I'm gonna roll it. 10 raised to the x equals 1,000. And 10 to the third is 1,000, so x equals 3. Three more. Ooh, on these next two, I've got a number out front, so don't forget that number out front is the same thing as an exponent. So I'm gonna do 3 to the x equals 9 to the second. 3 to the x equals 9 squared. Well, if I want to make 9 have a base of 3, 9 is 3 squared. So I'm essentially doing 3 squared. Whenever you have two exponents, if I'm doing a power of a power, we multiply those two numbers together. So that 9 squared is the same thing as 3 to the 4th. And that's helpful because now my bases are the same, so I can write x equals 4. Any questions so far? Similar for the next one. This one's just got a 2. Don't forget to bring that 3 to be an exponent for the 8. So I'm going to do 3 to the x equals 8 to the third. Well, 8 is the same thing as 2 times 2 times 2, so 2 to the third. So 8 is the same, 8 to the third is 2 to the third to the third. Again, we multiply those numbers together, so it's not 2 to the 6th, it's 2 to the 9th.
I have a question.
Yeah.
Because I was doing it a different way. Could you just take like 8 to the third and then put like 2 and then it's like to the x equals and then like 5/12 and then find it from there?
Mm-hmm. Did you get
Okay.
9 too?
Yeah.
Yep. Mm-hmm. Another way you can also do it is if you're confused by like this part of it, is I know that I can write, let me just write in a different color in the middle of this. So 8 times 8 times 8 is 8 to the third. And every time we write 8, it's 3 2s. And so we can do that. Oh God, what is happening? There's 3, and then 1, 2, 3. And then we can count that that's 9 too. So there's a bunch of different ways to look at this. Sorry, I thought that was going to look more helpful than it was. It did not look that helpful. My bad. All right, last one I think on this page. I've got e raised to the ln of 4. Again, ln is like log base e, so those cancel out, and I'm left with just 4. All right, any questions so far? We just did a ton of examples, lots of properties of exponents there. All right, let's keep rolling. These are very, very similar, but now my x is in a different place. So I'm still doing my log roll. I've got log of x equals 3. I don't have a base, so I'm going to write 10 in for my base. I'm still going to log roll. But instead of having my x as my exponent, now x is my answer. So I'm doing 10 to the third equals x. And I just have to solve 10 to the third, and that's my answer. So 1,000 is x. So my difference here is my variable is what I'm doing my log of. And so my answer is not going to be the exponent. It's going to be like the number raised to that power. All right, so let's keep going. The next one, again, no base, so that means base 10. So log base 10 of x equals -1, log roll. I've got 10 raised to the negative first equals x. You can either make this a decimal or you can make it a fraction. So 1/10 is a perfectly acceptable answer, or 0.1. Both of those are the same thing as x. Questions so far? All right, same thing, keep rolling. This one's 10 to the negative second equals x. Some people want it to be like 1/20 or something with a 2. Remember, the square means I'm multiplying 10 by itself twice. So you can think of it as 1/10 squared, and we know 10 squared is 100. Or we can just move the decimal place back 2 places. So it's not just 0.1, it's 0.01. Whoa. Questions so far? Okay, keep rolling.
I'm sorry, I just had a quick question.
Go
So
ahead.
in this scenario, do you always have the little one in the circle as 10?
Yes, because there's no base written right now.
Mm-hmm. Oh, the base. Okay, got it.
Yes. Now we're about to switch it up though, because do you see how the next one says ln?
Yes.
That means its base is e.
Okay. Log. Okay, got it. Log is the b and ln is the e. Got it. Thank you.
Mm-hmm. Log without any base is a 10, and ln has a base of e. All right, so now I'm rolling. This time it's e to the 4th equals x. Cool. You can leave it as e to the 4th, or you can use your calculator. And I poorly did not think to put it up, and I just don't feel like there's enough time to waste on that. So you can press second ln and raise your e to the 4th. And I got 54 point something, something, something. Or you're welcome to just leave it as e to the 4th. Either answer is correct. This one would be 54.6 equals x, or just e to the 4th is an acceptable answer. Next one, exact same idea. ln means base e. E raised to the 6 equals x. Totally, no, not anything that I'm writing. There we go. E to the 6 equals x. Again, leave it like that or plug it in. E to the 6 in the calculator is 403.4 equals x. All right, we've done 5 like this. Any questions so far? Okay, the next ones have some exponents and some fractions, so let's go look at what those look like. Again, log with no base means log base 10. So I'm going to do 10 to the 3rd. Oh, I didn't switch colors, whatever. Oh, don't forget this guy. The 3 out front means that I'm doing an exponent of 3. No, not there, sorry. Here. Oh, I got a lot going on. Start over. Okay, take 2. Log with no base means I've got a base 10. The 3, however, means that my exponent goes with the number that we're doing the base of. So in this case, it's x. So I'm doing log base 10 of x to the 3rd equals 3. We can still log roll that. 10 to the 3rd equals x to the 3rd. All right, pause. They both have an exponent of 3, which means that the base must be the same. So that means that x must be 10 in order for this statement to be true.
Can you re-say that?
Mhm. When I moved my exponent of 3 up to the x, that gave me log base 10 of x to the third equals 3. So then I log rolled it to get 10 raised to the third, 10 raised to the third equals x to the third. The only number raised to the third that's equal to 10 to the third is just 10. I can't raise another number to the third power and get the same number as that. So if my exponents match, then that means that my bases must be equal to each other. Did that help, or do I need to do more?
That makes sense.
Awesome, awesome. Thanks for clarifying, Ava. Next one's very similar. Let's do that one. Again, I've got an exponent this time of -2, so we're going to bring that -2 with the x. It's ln, which means it's base of e. So I've got e to the fourth equals x to the -2nd. And this is kind of weird. In order to solve this, let's do some simplifying. We want x all by itself. Let's first move that x to the -2nd. Let's flip it into the denominator so I no longer have negative exponents. E to the fourth equals 1 over x squared. The next thing I probably would do would be to get rid of the fraction. So I had to get a fraction to get rid of the negative exponent. In order to get rid of the fraction now, let's cross multiply. So that would give me e to the fourth times x squared equals 1. If I divide and move the e to the fourth to the other side, then I can get x squared by itself. And then the last thing I would do to get x all by itself is square root both sides to get rid of the square. So x is about good. Square root of 1 is just 1, that's good. And then square root of e to the fourth, well, e to the fourth is e times e times e times e. So I've got 2 pairs of e's, and so I can take 2 e's out. So I'm left with e squared. E to the fourth as a factor tree would just be e times e times e times e. So I have 1 pair of e's, so I get to get 1 e out, and then I've got another pair of e's, which means that I have 2 e's out, which is how I got e squared. Kind of funky, but it's okay. Mathematically, it all worked out. Questions on that one? The only reason we had to do a little bit more work is that we were given a -2nd as an exponent, and I can't just leave it as -2. I got to do something to it. All right, we've got a couple more here. Now all of these are fractions. What is that going to do for us? Log with no base is 10. So I'm going to log roll. This means 10 to the 1/2 equals x. Remember that your 1/2 as an exponent is a square root. So instead of writing that, I'm going to write radical or square root 10 equals x.
I thought it would be like -2 or something.
-2.
Since that's like a fraction.
Okay,
as
very
the
good
exponent.
question. This could be written as 2 to the -1st. But then that would be like 10 to the 2nd to the -1st. And that's like a lot of powers going up.
Oh, wait, I see what it is. Never mind. I see what you did.
That's a great point though, Ava. But since it's going to become our exponent, we'll leave it here. Very similar for the next one. Log no base means it's a base 10. Ooh, yuck. Of x equals 1/3. So log roll 10 to the 1/3 equals x. And if it's raised to the 1/3, that's just a cube root of 10. No need to simplify, and actually we can't simplify. Same idea for the next one. ln of x equals 1/4. Remember, ln is base e. So I can do e to the 1/4 equals x. The only way we can simplify that is make that 1/4 a fourth radical. So fourth radical of e equals x. I'm sure there's a better name for it. I just don't know it right now. Quartic root, I guess. Quartic root of x, or of e equals x. Kind of ugly. Okay. Any questions so far? Okay, I actually do want to show you a couple calculator things before we leave. So we're not doing, you're welcome to do 3.3 homework. I will not grade you yes or no on that. So those are good points to know how to do, but to keep your plate a little bit lighter today, we will not have 3.3 homework due. Let me share my calculator with you really quick. Just I want to kind of remind you a couple of things you should know how to do on the calculator. Okay, give it a second. It's warming up. Man, if it decides to turn on, that'd be cool. Oh, here we go. Okay. All right, screen share, calculator. Okay, so that's just a picture from yesterday. Remember that the log and the ln's are down here in the left side. So if I press log, it's assuming it's base 10. So if I press like log of 5, it's assuming I'm doing log base 10 of 5. Now, not all of our logs have that base. So if we want to do another base, let's say, I can annotate on the screen, right? This is about to be interesting. So if I wanted to do log, oh Jesus, base 7 of 10, I would have to do that as a fraction in my calculator. I'm going to do log of the bigger number, like bigger in size, not bigger in actual value, but bigger in size. Oh no, stop. I would do log of 10, and then I would divide that by log of the base. Log 7. So by plugging this into the calculator, that's the same thing as if I could evaluate this by hand. Now, you guys might have fancy calculators that do that for you. So I think maybe if you press math, here, wait, let me quit out of this. If you press math and you go over to, oh, this is way easier to do in person. And this is not on your quiz, it's just an easy thing. I think it's this log base number. So if you go to math and you click on this capital A, it gives you the opportunity to write like a new base in, so you can do base 7, and then you can do of a bigger number. And some of your newer calculators do that a little bit more automatically. I had to go to math, but if I press that, log base 7 of 10 is this 1.18 number. And if I did it the way I just showed you, so when I was in high school, we didn't have calculators that could do this. I could do log of 10 divided by log of 7, and that should give me the same answer. So I could go more in depth on calculator things, but if that's something you wanted to do or you've seen before, I just wanted to remind you that you could do that. Okay, I will stop my share. I will stop my recording.